Hello. In the last video, we talked about the difference quotient. In this video, I want to talk about how the difference quotient can be used to determine the equation of a tangent line. So let me remind you of what the difference quotient is. Okay, so using this, I want to focus on an example. And the example that I would like to choose is f of x equals x squared. So when I write down the difference quotient, I'm going to have two unknowns at this point, c and h. Now, the goal here is to substitute wherever we see an x, we're going to substitute in c plus h. And then for this expression, we're going to substitute c in for x. So for this particular function, we wind up getting c plus h squared minus c squared all over h. Now, in the last video, we talked about the purpose of h. H is the distance, is the delta x in the problem. In this case, if we set h equal to 0, what do we get in the numerator? We wind up getting a 0, and the denominator we get a 0, and that's a bad thing. We will never substitute in h equals 0 at this stage of the game. I mentioned earlier that we're going to have some algebra techniques involved. In this particular problem, I want to multiply out this expression, and hopefully some nice things happen. So multiplying out that numerator, I get c squared plus 2ch plus h squared minus c squared. That's in the numerator from over here. Now what do you notice? C squared minus c squared. So I have 2ch plus h squared all over a. Now, the student with the astute eye, you should notice that there's an h in both of these terms in the numerator. I'm going to factor that out. H times 2c plus h all over h, and then let's cancel the h's. I get 2c plus h. This is the most simplified form of the difference quotient. This is true for any value of h and any value of c. One of the ideas that we wanted was h should get as close to 0 as we can. So this idea is called a limit. Setting or taking the limit as h goes to 0, we get 2c. Now what does this 2c mean? I'm going to switch over to a Mathematica display, and I'm going to graph both y equals x squared, and I want to figure out how to use this. So how do I use this 2c? Well, let's be a little bit more detailed about this. Let's assume c is equal to 3. That means the slope of the tangent line is 3 times 2. Why do I write it like this? C is 3, but this over here is the slope of my tangent. So now we have a slope of 6. In the previous video, I talked about the point slope formula. At least I listed it. So point slope formula looks like y minus y1. Well, what is y1? Well, y1 is if I take the value of c, plug it into the original function, that's going to be my y1, is equal to the slope, which we computed to be 6. X minus the value of c in question. So this is in point slope formula. Personally, I like to write it like this. These are algebraically the same. Bottom one is a little bit easier to use in Mathematica. Let me verify all this by plotting the equation and its tangent line on the same plot. To do so, I need to enter in some functions. At this point, I'm ready to plot both of those functions. Now, remember, when I'm dealing with two functions, I need to put them in curly braces. I'm going to plot f of x and then g of x. Remember, I also need to put in the variable in question. Now, in previous videos, I talked about knowing the minimum and maximum value for x. In this problem, we actually have a good idea of what to use. What is the most important value of x? If I look back at the equation and the problem itself, the value of x that we want to focus on is x equals 3, specifically the point 3, 9. So that gives me an idea of where to set my minimum and my maximum. I want my minimum and maximum to contain x equals 3. So in this case, I'm going to pick 0 and 6. I'm just going to try to be symmetric. 3 below, 3 above. Hit Shift Enter, and I get my plot. Just as a reminder, when you're plotting more than one function, it is sometimes nice to put in the plot legend. If I type slow enough, a lot of the stuff is done. Hitting Shift Enter one more time tells me the blue curve is f of x, which we already know is x, and g of x is my tangent. If I look at this very closely, well, it looks like it's a tangent line, and that is great. Hopefully you found this video helpful. I'll see you later. Have a great day. Bye.